All right, today we're gonna peel back the layers on something you're using right now, this very second, but you probably never even thought about it. We're talking about the secret map that powers the entire internet. So how in the world does this invisible map actually work? Let's dive in and find out.
Welcome to Super Courseva. Unlock the secrets of the internet and master computer networking. Let's dive in.
I mean, just think about it for a second. You hit send on an email, and that message gets chopped up into these tiny little digital envelopes called packets. And poof, they arrive halfway across the world almost instantly. It totally feels like magic, right? Well, guess what? It's not magic, not at all. It's just a really, really clever map, and today we're going to show you exactly how to read it.
Okay, so at the very heart of this whole system is the humble router. Yeah, you've got one sitting in your home, but these things are everywhere. They're silently and super efficiently acting as the internet's traffic cops, its master navigators. And what's wild is that their power doesn't come from some crazy complex AI. Nope, it comes from a surprisingly simple list of directions.
And get this, what's really cool is that the very first routers, they weren't these fancy specialized boxes we have today. They were literally just regular computers. Seriously, just a computer with 2 network cards and a list of directions that someone manually typed out. That's it. And that super simple idea is still at the core of how the entire internet works.
And this map is called a routing table, by the way. It isn't just for those big, beefy routers. Any device that needs to talk on a network has its own version. Your laptop? It's got one. Your phone? Yep, it has one too. Every single device has its own personal little map to find its way around the digital world.
So, the big question is, how does this map actually work? Well, it's way simpler than you might think. We're about to decode the whole thing. This map is really just a simple database, kind of like a cheat sheet, with just 4 essential columns that answer 4 very simple questions. And here it is. This is the key. This is what makes it all work. For every single packet of data that flies through the internet, a router just looks at its table and asks these 4 questions. Where is it going? Who do I send it to next? How far is it? And which door do I push it out of? That's the whole game. Okay, let's break it down real quick. Destination is just the address of the network it's trying to reach. Think of it like a zip code. Next hop is the IP address of the very next router in the chain. It's basically the router saying, look, I don't know the whole route, but I know the next guy to hand this off to. Then you've got metric, which is all about distance. It helps the router pick the best, shortest path. And finally, interface is just the physical door, like Ethernet port 1 or port 2 that the data needs to go out of. That's it. That's the entire logic. All right, so now we know the 4 questions. Let's see how a router actually uses them to make these super smart split-second decisions on the crazy, chaotic, always changing internet.
Okay, so here's a great question. Your router at home, its map is pretty small. It only knows about a few local networks. So, what happens when you try to go to a website that's hosted in, say, Japan? As far as your router's little map is concerned, that destination is a total blank. And this is where the ultimate safety net comes in, the default route. It's this one special entry in the map that basically says, hey, if you've scanned the whole list and you have no idea where this packet is supposed to go, just send it to the big guy who knows the way. And that big guy is usually your internet service provider. It's the when in doubt, pass it on rule of the internet. Okay, now let's talk about that metric column, the how far question. So imagine there are 2 ways for your data to get from New York to London. Path A has to jump through 5 routers. We call those hops. Path B, well, it's a bit more scenic. It goes through 12 hops. So a router's whole job is to be efficient. It looks at the metric for both paths, sees that 5 is way less than 12, and it's a no-brainer. The crucial thing to remember is that it will always choose the path with the lowest metric, the fewest hops. It's going to pick path A every single time. But the internet isn't static, right? Things break. So what happens if a ship's anchor accidentally cuts that super efficient deep-sea cable on path A? Is your connection just dead? Is it game over? No way! Absolutely not. And this is where the genius of the internet really shines through. See, all these routers are constantly talking to each other, using these special languages called routing protocols. The instant path A goes down, they all gossip about it, update their maps, cross it off the list, and instantly start sending all the traffic down path B instead. There's no central boss telling them what to do. It's a self-healing system. It's amazing. Okay, so understanding the logic is one thing. But what makes this whole process truly mind-boggling is the sheer scale of it all. Going from your tiny home network all the way to the very heart of the internet.
So let's start at home. Your home router? It has a pretty chill job. Its map, its routing table, probably only has, 5 to 10 rows in it. It just needs to know about your laptop, your phone, and where to send everything else. That's it. Super simple.
But now, let's zoom way out. Let's look at a core internet router, one of those massive beasts that connects entire continents. Its routing table doesn't have 10 rows. It has millions of known networks, each one with its own little entry in that simple 4-column map.
And here it is. Here's the final piece of the puzzle that should just blow your mind. That giant router, it has to scan through those millions of rows for every single packet of data that passes through it. And it does this millions of times a second. I mean, just try to wrap your head around that. The engineering that makes that kind of speed possible is just staggering.
So really, the main takeaway here is that the internet's instantaneous, almost magical feeling, it isn't magic. It's the result of an incredibly elegant, logical, and unbelievably scalable system. At the end of the day, it's just a really, really good map being used with incredible speed and efficiency.
And that invisible map is what makes our entire modern, connected world possible. Kind of makes you wonder, doesn't it? What other incredible secrets, what other amazing feats of engineering are hiding right there in plain sight, just doing their job every day? Thanks so much for joining me on this one.